Welcome to a lesson with Dr. Powell. Let's take a look at structure preservation of merges of power sets. So suppose we're going to represent our power sets with ones and zeros. So suppose we have a power set with 5 things in it. So we're going to have 5 different positions for ones and zeros. So in particular, this represents a subset where we take that element, the first element, the third element, the fourth element, if we listed out the elements in order in some way or another. So this would be like a subset. So let's suppose that we've labeled all our subsets in such a way. There would be 2 to the 5th, so 32 subsets. I won't draw a Hasse diagram for that, but we have 32 subsets. And let's suppose that we wish to perform a merge, which is like a function where we're just kind of merging different things together. So kind of grouping things into fiber blocks, that'll make a function. But then we're just kind of renaming that whole fiber blocks, giving it a name. And that would be considered a merge. So we want to merge, which is like a function that preserves structure. And the structure that we want to preserve is intersection and a union structure. So anytime we have a sentence like A union B, so union intersection, A union B is C, then we want, so suppose this merge is like a function F. Then we want F of A, and then we need an image of the union. F of B will be equal to F of C. We'd also like F of A, and then the merge of the image of whatever intersection mean, an operation there. F of B, we want that to be F. So we want that to be, so in particular, if we had A intersect B is equal to D, then we'd want this to be F of D. So we'd like these ideas to hold. Now we're going to use the fact that every single merge of this type follows a basic idea, and that of ignoring or blocking out. Especially with this notation, it works very well. So that means that that we can actually label the fibers of this particular merge in the following way. We just kind of block out some entries. So here's a merge that works. What if we block out the first 3 entries? So we can block them out. And usually I think what we do is we say maybe we could just use blocks. So block, block, block. And then we kind of think, okay, and then let these guys be we let the entries be. So let's see what this means. So let's just, for instance, take a subset like 1, 0, 1, 0, 1. Okay, and let's see where it would go. Well, this particular map means that the image of everything always has 3 blocks in it. So 3 boxes at the beginning. If I decided my merge to behave this way, then I just put exactly what there is there and just put it here, 0, 1. So that would be the image of this. Now, this type of merge is the only kind of merge, at least this boxing merge. So, I mean, I don't have to just put 3 boxes at the beginning and put boxes anywhere, but putting boxes to ignore certain spots and then just, filling in what it is there. Those are the only kinds of merges that actually preserve the both of these guys. So keeping that in mind is will help us with the following question. What if we had one of these merges and we wanted to create one of these merges, and at minimum we knew that we absolutely had to merge this guy together and merge, so we had to merge this one and we had to maybe merge, let's see, let's merge this, merge this one together. Okay, so we know we have to merge these two. Okay, well, if we merge these two, let's just think of a block merge that actually at minimum would make this work. So you notice we want them to have the same image, right? But there's some places that are different. Well, like what's different? Like right here, that's different. Well, why don't we just put a block there, cover up what we don't like, what looks different. Cover up what we don't like here, because that looks different. Cover up what we don't like here, that looks different. But we can keep these, right? Because they're the same. Well, there's your block map. It's just simply going to be star, box, box, or block, block, star, block. Okay, that's going to be your function. So that means that that we know exactly what the merge should be for this particular power set structure. So so let's try it out. I mean, what if we take like 0, 1, 0, 1, 0, 1? What is going to be the image of this in the map? That's going to be, well, you just simply block out. So you block out these entries, and you're going to block out the last entry. So it's going to look like 0, block, block, 1, 0. Let's see, did I do that right? I think I wrote down 6 things. That's why it wasn't looking right. Okay. Block right there. There we go. And then we're going to have a block right here. All right, something like that. Okay, so notice that's it. Okay, so this is that's going to be what the image of 0, 1, 0, 1, 0 is. It could be this. So we're just allowing those to be the images, of course, that can represent a merge. We did a slight relabeling, but we're labeling the whole fiber by the same thing. And so, but they essentially it's like what I'd call a merge function that preserves structure. What's in this? So let's take a look for a minute and think. We know that this and this are in the same fiber. What else are in the same fiber? And how many different things are there? Well, well, I can just basically change up anything here. I mean, I know that I'm going to have 1 and 1, but really I can fill these boxes in with anything and it doesn't matter, and it'll have the same image. So the fiber is just anything I can, any way I can change this up and still have the same thing. I mean, I can have 2 options for this, 2 options for that, 2 options for that. So there'll be 8 total things in my merge, 2 times 2 times 2, or in the fiber that are going to be merged to this particular one element. And let's list them out. So we could have 1, 0, 0, 1, 0. We could have 1, we could do 1, 0, 0, 1, 1, or we could do 1, yeah, let's see, 1, 0, 1, 1, 1. We could do 1, 0, 1, 1, 0. Okay, so we have 4 so far. Okay, and then we can take, so we have these options, so 1, 0, and 1. We have 1, 1, or 1, 0, or 0, 1, or 0, 0. And then we could take all of those again and just simply put in, so let's just copy and just put a 1 right here in each one of those places and have 0, 0, 1, 1, and 1, 1, 1, 1, and 0, 1, 1, 0. So notice you have 8 things and they're all different, yet they all have the exact same image when you just simply ignore those 2 entries, ignore that entry, ignore these 2 entries, ignore that entry. Kind of a nice idea that anytime we have a function or a map, a merge that preserves a union intersection structure, it's always going to have this block out ignoring type feature. And you realize that's what intersection does. Intersection, what it does is it ignores anything that's not the same in both sets. And so for sure, you're kind of ignoring thing there. And when you're union onto something, all that's important in the union is what's new to union onto something else. So if you have something you want to union onto it, what makes the difference is if you have something else that's different outside of it. So you can really kind of almost just block out and ignore what you have to start with. Like if you're unioning onto a set, you can kind of ignore that and just focus on what you're adding to. So it's kind of, both of them kind of have this nice feature going in whenever you're merging. Thanks for watching.